The theory of constraints is a way to improve how a system or process works by finding and fixing its biggest weakness. This weakness is called a constraint, and it is the one part of the system that slows everything else down. The idea is that no matter how many improvements are made in other areas, the system can't move faster than its slowest part. Once the main constraint is found, the goal is to make it work better or remove it. This method helps people and organizations focus their energy where it matters most so they don't waste time fixing things that aren't the real problem. Now let's look at some examples. Imagine a school cafeteria where students have to wait in a long line to get food. If only one food station is open, that becomes the constraint. Even if the rest of the cafeteria runs smoothly, the line will stay long until that bottleneck is fixed, maybe by opening more stations or making the line move faster. In a factory, a machine that runs slower than all the others can hold up the entire production line. If that one machine is improved, the whole system becomes more efficient. These examples show how focusing on the constraint helps improve overall performance. Now let's explore some strengths of the theory of constraints. One strength is that it helps people focus. Instead of trying to fix everything at once, it identifies the most important problem and puts energy into solving that first. This saves time and resources. Another strength is that it's easy to apply in different settings, like businesses, schools, or even personal projects. It works well because most systems do have one major weak point that limits everything else. A third strength is that it encourages constant improvement. After one constraint is fixed, the next one can be found and improved too, creating a cycle of progress. However, the theory of constraints is not without its weaknesses. One weakness is that it can be too focused on just one problem at a time. While that helps with clarity, it might ignore other areas that also need attention. Another weakness is that it assumes there is always one clear constraint, but sometimes problems are caused by several small issues working together. If the wrong constraint is chosen, time and effort could be wasted. Also, fixing one part of a system might create a new problem in another part, especially if everything is connected. This shows that while the theory is helpful, it needs to be used carefully. Now let's consider some alternatives to the theory of constraints. One alternative is lean thinking, which focuses on reducing waste and improving flow across the entire process, not just at one weak point. Another option is Six Sigma, which looks at data and statistics to find and fix defects or errors in a system. A third alternative is systems thinking, which looks at how all parts of a system interact and tries to understand the big picture rather than focusing on just one constraint. These alternatives offer different ways to improve performance, depending on what kind of problem needs to be solved.